Summit in Washington, D.C. My name is Shalisa Chambliss, and I am your room host for today. I just want to start with a couple of quick announcements before we get our speakers on the stage. Number one, I want to make sure that everyone has downloaded the AWS America's Events app. If you're on iOS, it is available in the App Store. If you're on Android, you can download it via a website or use the QR code on our posters available just out the door and to the left. You can use the app to build your schedule, to complete surveys, which we ask that you do after each presentation that you attend, and also just to engage with the summit overall. The session is being recorded, so please at this time, I'd ask if you haven't done so already, silence all of your devices. During our Q&A session, this microphone will be available in the center of the room. I would ask that you approach the microphone to ask your questions so that they can be heard by the audience and on the recording. So without further ado, presenting You're in the Cloud, Now What? Please welcome to the stage Adam Clater from Red Hat and Trey Vance, Senior Solutions Architect, AWS.
Way to the stage here. Okay, this thing's on. Excellent. So, welcome, Adam.
Thanks, Trey. Can you hear me now? Yes? Wonderful. Thank you.
Awesome. Yeah, so we're going to go ahead and get started. Everyone, we want this to be interactive, so hopefully you have some questions for us towards the end. Some related breakout sessions, right? The recently announced Authority to Operate Compliance as Code by Tim Sandage. That's going to be going on a little bit later today. Laying the groundwork for change. Cloud culture starts at the top. That's Rigo Garcia. That's also a related topic. And then creating hot lanes to the AWS cloud. So go ahead and check those out. And Shweta is going to be giving that presentation as well. So what we wanted to do, you're in the cloud, now what? Kind of sounds like a failed sitcom on Amazon Prime. But thank you for that.
It could be successful.
I extremely appreciate the applause for that one. We want to talk to you about some of the things that our customers have been seeing, some of the things that have been challenges, and then some of the ways that people are using both Red Hat and AWS to solve these critical business problems. So one interesting thing, AWS, in a lot of ways, has been referred to as building blocks or Legos, right? So AWS has a number of services. So I thought we'd start with something kind of fun, right? Back in 1974, I was not there personally, but in 1974, in the Lego magazine, there was actually a problem that was posed, which was how many combinations could you make if you had 6 of the same bricks? So if I have 6 Lego bricks, how many combos can I make? The assumption at that time and the math at that time said that it was just over 105 million combinations that were possible. Turns out that number was wrong. And not only was that number wrong, it was really wrong. It was wrong to the tune of about 8 times, roughly, doing math in public. And it was over 915 million variations. So it's like, well, how could they get that number that wrong, right? And it was because initially they had accounted for an assumption, and that assumption was that they were going to build something to a maximal height. So if you have 6 bricks and you're doing patterns, apparently you can do 102 million patterns at the maximal height. But if you didn't go to the maximal height, then even more combinations of bricks were possible, right? And now think about that when you're thinking about things like going into the cloud, right? So how did they miss that? Again, it was essentially the design intent was to do something that had a maximal height, but not the other combinations. So many more possibilities were available, right? And as we're building new software and we're beginning to modernize things that we're doing on premise, you can see that all of the available partner and AWS technologies, some of the things that you've built yourself. You can put a tremendous amount of different kinds of technologies in place. You have a lot of possibilities. So today what we're going to try to do is we're going to try to show you some patterns that customers have found that have been successful, joint customers that we've had both of AWS and Red Hat. So we're going to start talking about some of those things. And just remember that the typical issues that organizations have as they're getting out of the data center and they're moving into the cloud is they have all these applications that may be stovepiped, or they may be things that were written at a time where the documentation wasn't solid. They weren't following these DevOps processes, the agile methodologies, things that we're doing today as we build modern and kind of decoupled applications. Some of those things weren't done when the applications that we have to move into the cloud are being used, right? So we kind of have to engineer around that. So we have to take this and make something meaningful of it. And this is going to be a really interesting presentation. Give us just a moment. We're having some technical difficulties. Folks, this is live, so anything can happen. Anything and everything can happen. So hopefully you guys are seeing this and take care of that.
Yeah.
You guys
So
in the back?
I do appreciate on the first slide that all the bricks were red, right? I want to thank you guys for that.
Yeah.
Because,
We
we
put-
think
we
all
put a
the
lot of thought
foundational
into it.
building blocks are red.
The
So,
foundation is red, right?
That's right. Yeah. So we appreciate that.
Absolutely.
And we have had a technical disturbance in the force.
That's right.
So quick survey of folks. Who here is kind of a ops or a dev kind of technical person? Handful of folks. And then how many folks are really from the business side looking to transform what they're doing and okay, cool deal. Very good. And then some of you didn't raise your hands. How many are here just for the free lunch? We have a handful of those. Yeah, Marty? All right, good.
All right.
Good to hear.
Those are the ones that work with you, right?
Yeah. Those are all the red hatters. They're like, we're just here for the free lunch.
There you go.
They've heard this presentation time and time again.
Yeah, there we go. Okay, so we're restarting here. So
All right.
I'm going to go all the way back to the beginning, and we're just going to restart that whole thing. So does that work for everybody? No, just kidding.
We've got a live countdown clock. It's 4 minutes and 32 seconds remaining, so we're going to see how this goes.
Yeah. Okay, so we're going to go from a blank presentation. Let's see how that goes. So as we were, I'll just go on without the presentation. It's fine, But one of the things we wanted to talk about is this idea of layering, right? So building blocks. So we're taking the things that we do well, the core infrastructure, the ability to scale up and scale down, to leverage things in the cloud. We're taking those things and then we're adding patterns to it. So there's a lot of people who are builders, right? They build applications, they're intuitive, they want to consume all of the different services. That's great. Every organization, though, is not that way. Some people like patterns that they've been done either tried and true, or someone really understands the direction that that their organization is going. Maybe they have a compliance regime that they have to adhere to, right? So if I have to deal with compliance, whether that's PCI or if I'm in the public sector space, maybe I'm trying to adhere to FedRAMP or a DoD impact level 2 or 4. I want patterns that have been vetted, that have visibility to them, and have ways of working so that I can accomplish the business task, I can accomplish the mission, and I can go and do this, and I can also continue to iterate, right? So I can take that monolithic application from 20 years ago, and I can take a component of it, and I can modernize that component, and then I can move on in an iterative fashion to other parts of that application until I do have a truly modernized application and a new solution, something that can be maintained, something that follows best practices for security, that's something that has reliability built into it, not because it's on a reliable infrastructure, but because the application itself could be self-healing, has automation to it. So there's lots of different ways for us to incorporate these new patterns and new designs. What I often see is I don't need this anymore because we still don't have a presentation. What I often see is I see organizations coming into the cloud in a couple different ways. We have organizations that are cloud migrators, this idea that an organization has a fixed amount of time that they have to move into the cloud. They have a mandate to do cloud first, so their data center is going to close within 180 or 180 days or a year or 18 months. So those organizations are taking the applications that they have with them, with all of the components that exist today, and then they're going to move into the cloud and modernize the application after. We have organizations as well, like the cloud forward organizations that have already made that move into the cloud. They've already invested in the new technologies. And now those organizations are starting to incorporate new services into the mix. So those cloud forward organizations have already learned all those other lessons, and now they're starting to iterate and innovate in the cloud. And finally, we have these organizations that were kind of born in the cloud. They use the cloud as something that was necessary for their business to function. Maybe the cloud gave them a competitive edge because they were able to just pay for the resources that they were going to use, and they were able to scale up or scale down or experiment very quickly in the cloud. So we see all of those different types of patterns when it comes to going into the cloud. And that kind of simplifies some of the choices. And we're back.
All right, just in time.
So we talked about these things. Remember the red bricks? Those are the ones that Adam liked. So we're going to keep moving through this. And we're going to get to some of these other, nope, failed again. All right, so that's not awesome.
All right, so while I think we may have a few minutes of time here while we wait for some of this to come together. What are some of the best practices that you're seeing agencies sort of take to? You mentioned automation around security. Where are folks going with that?
Sure. So one of the things that I see, so the role that I have really quickly is I'm actually the lead architect for a program called ATO on AWS. And what that program does is it allows us to create some patterns working with our partners, such as Red Hat and some of our integration partners as well. Those organizations actually help to have the configuration rules, have the visibility all throughout what I call the software supply chain, right? So this all starts from source. So that first commit, those pull requests that come in, are they gated? Can I document that? Does that ultimately end up in my system security plan? Like, those are the things that I can actually do when I'm starting to use governance as code and infrastructure as code. I'm laying down things in a repeatable way using automation.
Right. So for Red Hat, part of that secure software supply chain for our customers starts with the bits and binaries that we ship even from the operating system up, right? So when you buy Red Hat Enterprise Linux or even the OpenShift platform, Red Hat cryptographically signs all of those binaries when we deliver them to you. And then you can do a validation of those every time that you deploy them, whether they're in your data center or in the cloud or wherever they happen to go to. And that's really foundational for that software supply chain. It's those bits and those binaries, actually, that go through things like FIPS 140-2, our Common Criteria EAL4 Plus certification. So if you're in a IA type of environment, DISA actually requires that you use something that has been Common Criteria certified. And so that software supply chain, the building blocks, we say, really starts with the operating system and builds up on that. So once folks sort of get that supply chain, then they start to look at containerization, right?
They do.
Where do they go from there? What does that look like?
So it's often an iterative process, right? So some organizations begin with running instances that have the particular applications, and then they start to look to dissolve that, right? They add things like queuing, they add a database service, and then they start to consume like the Kubernetes, and they start to go into the containerized realm.
Yeah. And so a lot of the benefits of containerization is that they're much more lightweight than, say, a virtual machine that you might be used to. Everybody's probably running, like raise your hand if you're running virtualization. We're gonna do lots of this. I'm gonna wear out your arms, I'm sorry.
There you go.
And so everybody's running virtualization at some point in their data center. And there were all of these promises of virtualization, right? We were gonna get this great server consolidation. We were gonna run fewer servers. And then we were gonna control like server sprawl. Then we invented this new word, virtual machine sprawl, which is basically we're doing the exact same thing. We're building one virtual machine for every application and deploying that into the data center. The good news is that we were able to consolidate a lot of those workloads from usually 10 to 1, right? We would take 10 physical machines and consolidate them down to about 10 virtual machines. But every time we did that, we were still deploying an entire operating system with that stack to sort of manage and control in that. And so the realities of containerization are that we can do yet another factor of consolidation, again, to go from maybe closer to 100 to 1 applications on that physical footprint. All right, are we?
We're past the point of trouble for us, so.
All right.
Okay. Yeah, so visually, this is another way to talk about these patterns, right? There's a whole decision tree in here, right? There's, am I going to rehost? Am I going to replatform? Am I going to repurchase? Like, multiple organizations do all of these things, right? And you may be doing several of these things at the same time. So there may be something that works very, very well in your, your order entry system or your inventory modules, but you may want to go outside of that and kind of decouple one system from another. So these architectural patterns help us to kind of reinforce some decisions that we're making in the biz. So how are our customers building their ways forward, right? So continuing on with the building block theme, we do see some of the AWS services and kind of the AWS cloud as one of those foundational pieces, right? And so as you layer your cloud journey, you're able to use one of this was current as of yesterday, right? So there could have been an announcement that I missed in Teresa Carlson's keynote, but there are 21 geographic regions around the world, including multiple regions now for the AWS GovCloud. 66 availability zones. So a lot of ways that you can build in resilience, you can build in customer customization for locale, and 165 fully featured services. So that's a lot of bricks. So that's a lot of combinations to make possible. Some of our joint success stories in years past, we've actually had the US Navy team talk about their application modernization for the warfighter. We've had organizations such as Cathay Pacific, which is an airline, talk about the challenges of doing both customer service and real-time data analytics to optimize load on a plane, or the revenue in seats and things like that. So real-world examples of multiple iterations and use cases for our joint customers. Some of the tooling, so if we get tactical for a second here, we do have the AWS Services Broker for Kubernetes. And what that allows you to do essentially is to use multiple AWS services in an OpenShift environment. And so you kind of get the best of both worlds in that regard. You get to leverage services in multiple regions with consistency that's all API driven, and you're able to leverage that inside of a container environment so you can have a full rich experience. Getting that up and working is super simple. Like, it's just a couple of lines and a couple of gets, and you're on your way, right? And then this is an example of some of the things that you can use, right? You can use the ubiquitous encryption of KMS, things like secrets management and databases, and some of the AI and ML services such as Amazon Translate and Amazon Lex, to build the solutions that as you modernize your applications or you incorporate new features, you can incorporate those AWS services into the OpenShift environment. So it gives you as a customer a lot of choice, but there are also a lot of patterns that allow you to quickly get this up and running. We do have another service coming We've got the AWS Service Operator, which was recently announced. AWS participated in a joint effort with Red Hat to create the Operator Hubs. And the Operator Hub, as you can see there, operatorhub.io. This is in developer preview, so we're going to pretty shortly here have a lot that you can do inside of the Kubernetes world with AWS services, just from a different take. So more choices, more tools for you to have be able to have the right tool for the right job.
Cool.
There we go.
All right. This is me. All right. So thanks.
Absolutely.
So who's ever heard of Kubernetes? A couple of folks aware of that? All right. So it's an open source, really orchestration engine for managing containers. The interesting thing about Kubernetes, it was really the culmination of all the efforts that Google had sort of managing and running containers within their environment. So for years, you've all been using Google services, and when doing that, you've all been using applications that are running in a container. Every time you open Gmail, run a search, or even deploy a virtual machine in the cloud at Google, that was all done in a container there. Right? And so they've been doing that to the extent of like millions, if not billions of containers a day that they've been creating and destroying, and took all of that knowledge, put it into a document actually. They referred to their old system as the Borg, released that into the open source community, and now Google's the #1 contributor to that, Red Hat's the #2, and there's a variety of other folks. So talk about that. So Kubernetes is really for managing lots of containers. These squiggly line box things are really containers being run and orchestrated across Kubernetes. And so, you know, the idea being that a developer, he or she is going to write some code, they're going to put it into their code repository, something's going to happen, and then that's going to get deployed via Kubernetes across a cloud. And as it is, the entire industry is really converging on Kubernetes. There's a AKS, you guys have a Kubernetes service that's available within Amazon, so thanks for that. And a variety of folks are making huge contributions to it, which is great, and it gives you the understanding that this is really an enterprise-focused service for running containers at scale. So, you know, the reality is a lot of folks think, well, okay, I'm going to run this on my own. I'm going to run Kubernetes, and then I'm going to deploy this across my infrastructure. But as you deploy containers throughout your infrastructure, every single container has its own IP address. Right? And so we talked a little bit about the idea of consolidation, but we also talked about sprawl. And so if you think that virtualization sprawl has been bad, containerization is only going to go to the next level, right? Because as we break down those applications, as you mentioned, and divide them up and build new features and functionality in much more of a microservices-oriented world, we're going to have many, many, many more containers out there running. And if each one of those has its own IP address, needs its own load balancer, needs to have an understanding of what the routing is in your virtual infrastructure, then you're going to need some sort of layer to manage all of that networking. And it really does become an undertaking. It's not the sort of thing you're just going to manage on a spreadsheet and hand jam your own routing table. And so that's where things like Flannel and Weave and Open vSwitch have come into play. And so then, you know, it's like, okay, I'm going to do this, but all of a sudden I'm creating containers, and I'm doing version control of containers, and I'm managing all these containers. And so I fundamentally need a container registry where all those are going to be made available to my developers and to the constituents that I am servicing in that development environment. Red Hat provides Quay as our container registry in OpenShift. And so, you know, you could find yourself running your own. But then, yet again, it's simply not enough to have networking and a registry. You need to have monitoring and metrics. You need to actually understand what's going on in that containerization infrastructure. And so you could go and sort of build your own and build your own monitoring metrics around that. But you still really wouldn't have everything there, right? You need to build some sort of application lifecycle management into it. How do I do blue-green deployments? How do I do canary deployments? How do I retire an application that's old? How do I deploy new code into running applications? Kubernetes doesn't necessarily provide all of that. And so really the point is that raw Kubernetes isn't really ever enough, because of course you're going to need applications and services, and you may use some Amazon services in one instance, and you may have some internal services that you want to rely on, or maybe they're external at someone else's provider. And so the ability to manage and deploy all of those becomes critical in that environment as well. So the reality is Kubernetes is simply, in and of itself, not quite enough to build an enterprise-grade application platform and deploy that. Because we find all of these requirements. I'm sure each of you are running into these as you build out your environments. You may not have run into all of them yet, but at Red Hat, we have stumbled across all of these things and built them into the platform. Also, all these slides will be available afterwards, so don't feel like you have to take a picture of every slide. I'm not just calling you out. Lots of people do it. But they are going to be available online. And so anyways, you've got all of these capabilities. Container isolation. What's your security model and your containerization? I don't know. What does that look like? We've sort of got all of that built into OpenShift, right? It's really the container application platform for modern enterprise application development. The beauty of OpenShift is really that you can run it anywhere. Yes, absolutely. We run it in Amazon AWS. We actually have a huge hosted platform that we run. We call it OpenShift Dedicated, and we make that available. So we'll run and manage OpenShift for you, and you just sort of consume it as a service. That runs in Amazon. We have lots of customers that are running at Amazon. But of course, we also have customers that want to run it on-premise or in another cloud or building their own cloud, all kinds of places. The key, though, the reason we're able to do that, the reason OpenShift can run everywhere, is because it's built on open standards. Right? That's really where a lot of these things begin. And the great thing is that Red Hat is a massive contributor to these things. So I mentioned that Red Hat's the second largest contributor overall to Kubernetes. We're also one of the largest contributors to Docker and to containerization. We've actually built, well, not we, the community has built a new containerization standard just for using with Kubernetes called CRIO, which is a container runtime that is competitive with something like Docker. So the important thing to understand is just because I'm running OpenShift doesn't mean I need to go buy something from Docker or anything or anyone else, right? We sort of ship all of that to you. And as I mentioned before, it really starts with the operating system. This is where our security inheritance begins, whether we're running in Amazon or your data center or someone else's. And this operating system is Red Hat Enterprise Linux. It's the operating system that's been running Blue Force Tracker for warfighters. It's been running major FBI systems. It's been running everything. Every top-level cabinet agency is running Enterprise Linux. It's really the backbone of a lot of that infrastructure, and it's key for us to bring forth those security standards, certifications, accreditations that I mentioned earlier as well. On top of that, we layer Kubernetes, which we just got done talking about. We build a lot of functionality into Kubernetes for things like networking, storage, automation, security controls, which are wildly important in these environments as well. And then this developer experience, because at the end of the day, if your developers are interacting directly with Kubernetes, that's sort of one lifestyle, but it's a little bit raw, right? It's a little bit command line oriented. And so we have self-service portals and capabilities for carving up the infrastructure into quota units and deploying that and making all of that available. And so we think that's incredibly helpful. And then on top of that, we build the ability to have things like web and mobile containers, data storage, business automation, and integration available throughout the platform. The thing to understand is when you start to look at a lot of container platforms, you may be under the assumption that it's only for net new application development. I'm only going to use this if I'm writing a new application and deploying that. But as Trey mentioned, there's a lot of workloads that are coming out of existing data centers. And so for us at Red Hat, it was really important that we give OpenShift the ability to run existing applications. I remember one of the very first customers that I worked with on OpenShift years ago was very focused on getting a WebSphere application running inside a container on OpenShift. And we worked with the guys at IBM and got that containerized and figured out their licensing and moved all of that forward. And so that customer was able to migrate that legacy application into that container platform without having to refactor and rebuild that application. So it's hugely valuable when you start to think about the thousands of applications that may be at your individual agency across all the agencies in the government. Being able to put those into a container platform where you're not required to rebuild, refactor, redevelop those applications is wildly important. The other nice thing is I mentioned that Red Hat Enterprise Linux runs just about everything. And so every major ISV in the world has been building their application stacks to run on Red Hat Enterprise Linux. And so since containerization is so tightly coupled with the actual underlying operating system, you have the ability to run all of these languages and frameworks in the container. And just about any Docker image that's out there, you'll have the ability to run. So let's take a look at what that lifecycle looks like using OpenShift. So as a developer, I'm going to write my code, and when I'm finished for the day, or maybe once an hour, I'm going to make a commit into my upstream repository. It's going to go through some sort of CI/CD pipeline. Who's got a CI/CD pipeline where they're working today? Yeah. I love this concept of a CI/CD pipeline. I think it's really important that developers communicate to their operations organizations what the heck is going on in that pipeline. Because I think ops really has been there as part of the process of getting that pipeline built out, but maybe doesn't understand all the validation and the value that's coming out of that pipeline. We talk about things like security scanning, code quality checks going in there, automated testing. This really becomes the third-party validation for our ops organizations that the developers are not going to break production. And I think when they actually look at it that way, that's pretty enabling for an organization to say, hey, if this passed the pipeline, or, oh, by the way, I heard I could put this into the pipeline and get an additional layer of validation, then I think organizations run a lot better. And that's when we start to get to that true DevOps nature. So anyways, coming out of that CI/CD pipeline with all those validations, we're then going to create a container. And so with OpenShift, we have a technology that's called source to image. And so you set up a webhook in your repository, and as soon as that commit has been completed, it figures out all of the things that are required for that container, packages it up, builds it into a container, deploys that container into your container registry, version controls it, signs it, so that you know exactly what's going on from a software supply chain perspective of what's going to go into your environment, and then deploys that into OpenShift, right? And then OpenShift and Kubernetes manage that container in the platform. So who's doing this? Lots of folks are doing this. Even folks like, I was in Boston a couple of weeks ago at the Red Hat Summit, right, our user conference. And I had the folks from USCIS up on stage talking about their experiences and the transformational role that they've had to undertake as an organization to begin to consume and use these types of technologies in Amazon, by the by, in order to build faster applications and be more responsive to their end users and their customers. We've got a variety of other folks as well, Wharton, KeyBank, CA. CA actually took a lot of their applications and technologies and just completely rewrote them as a service technologies hosted on OpenShift. So you wouldn't be alone. This presentation, I feel like the front of the presentation is at the back.
Oh, really?
So we're going to see how that goes. Financial services customers have done it. Health insurance providers have done it. Open Innovation Labs. So Open Innovation Labs is Red Hat's residency program because we understand that not every organization is really ready to undertake this transformation, right? Building these robust pipelines, implementing Scrum and Agile. I know a lot of folks get credit for doing Agile throughout the government. I think a lot of folks are not quite doing Agile throughout the government. And so what we do is we partner with them and we have a 8 to 12 week residency where we sort of teach them how to live this lifestyle. And this is not simply for developers, right? We take developers, we take ops folks, we take product owners, we take Scrum Masters, we take the Agile folks and bring them all into the room and do amazing things like write a social contract. How are we going to work together as a team? Because in reality, we're not teaching you new technology, we're teaching you a new way to work, right? And so that social contract becomes really important in understanding how we're going to interact together, how we're going to work together. And it's going to sound kind of silly, but it's about building a lot of emotional empathy across the team and helping people understand that there's a lot of noble intent. This individual is doing this not because they want to destroy my production environment or because they want to take our service down for our customers. No, they think they're executing on their mission, and there may just be a misunderstanding there. So anyways, we do this, and what we find is this drives innovation through these organizations by helping them to understand these processes and how to move them forward. So this is a thank you slide. I'm going to skip it.
Okay.
No? Okay. So half my presentation isn't there. Yeah.
Wow.
So, can I get a?
I know what that feels like.
Yeah. Can somebody in the back give me an idea of where we are on time? I'm sorry. 15? Okay. All right. Cool. So, you want to do Q&A?
Yeah,
You think
let's do
now's
it.
a good time for Q&A?
Yeah.
All right. So are there any questions in the audience? I know we didn't actually cover all the things we wanted to. Questions?
Who's going to be first?
They're out there. Yes, sir. Please step to the microphone. Please step up to the microphone, sir.
OpenShift in GovCloud
Yep.
and the impact level 6 region.
I'm sorry?
Impact level 6 region, secret region.
Oh, in the secret region. So when he says secret, are you referring to C2S?
Right. So we actually have both the secret and top secret regions,
Okay.
right, which are separate from GovCloud. So GovCloud is for unclassified but sensitive information, and it has an accreditation from the DoD perspective up to impact level 5, right? So the secret region. So the question is, are there OpenShift services available inside of the secret region?
Yeah. So sure, we can deploy in GovCloud, absolutely. And then within, and help me out, is there a difference between C2S and secret, or are they one and the same?
So C2S technically is a contract vehicle, but
Fair.
secret region, sure.
That is the
so
secret
that is
region?
the same one.
Okay,
Yeah.
all right. So when we talk, I talk about C2S, that's just what it's known as throughout the industry. Red Hat actually owns and operates OpenShift equivalent to our commercial offering of what's available as OpenShift dedicated. So if you're working within that secret environment, we have a portal within that we actually run where you can go in and deploy OpenShift and have us manage that for you, or even on your own, managing and deploying it there. So yes, yes, and yes, I think is the answer to your question.
Yep.
Other questions? Just no, maybe? Jen, question? Come on, you gotta have something. Nothing? Oh.
What are the burning topics?
Yeah. Yes, sir. Microphone, please. Sorry.
Yeah.
Yes, we have systems admins who feel threatened by infrastructure as code and containerization.
Yeah.
What do you tell them?
Absolutely. So I was a sysadmin for like 15 years, and that
Same.
was one of the most mundane, repetitive jobs that I had in my entire life. There were two things that, actually, when I had that job, I described myself as a technology security guard, right? You didn't actually pay me for what I was doing that day. You paid me to be there in case something went wrong, right? And that's really the job of a sysadmin more often than not. We've got some deployment stuff that we do, but there's a lot of low time, downtime, where not a lot is going on. Those times, those emergencies, that firefighting, it's actually created more often than not by human error, right? And so when we talk about infrastructure as code, we're actually talking about getting rid of the worst times of a sysadmin's life, right? It's down, they're breathing down my neck, et cetera, et cetera. So that automation, that infrastructure as code eliminates those times. And so as that time gets freed up, we take those really smart people who have a really good understanding of our business processes and what we're actually doing, and we apply them to solving our actual business problems rather than being a gun-for-hire sysadmin, right? And I think that's a lot more valuable, but that doesn't just happen, right? It really means that management and a lot of other folks need to understand that there's a fundamental shift in the role that those people are doing and help move them into those business conversations where they've had no opportunity before. Now, I think that government folks especially get up in the morning and go to work because they're incredibly aligned with the mission of their agency. And so as a sysadmin in a government agency, I think I would be a lot more excited to be working closer to the mission than as just another Unix gun for hire. Cool. Other questions? I can talk about anything. No? Yes? All right.
Okay.
Call it done. Cool.
Yeah, well, thank you for coming.
Yeah, thank you all.
Adam, thanks for being here.
Absolutely.